Hi, this is Adrian calling from Live to Learn Academy, and today we're going to be going through lesson 4.2, Solving Linear Inequalities. For those of you guys who are not yet subscribed to the channel, feel free to subscribe for more tutorials like this for the Ontario Curriculum Advanced Functions. If you're somebody who needs tutoring, feel free to click the link in our description, and our team would love to reach out to you to help you ace this course. But without further ado, let's get straight into it. So, what is a linear inequality? Now, sometimes we may see linear equations look like this. 3x plus 5 equals 8x plus 2. We may see equations like this, and then the question will ask us to solve for x, right? Linear inequalities are very, very similar in that sense. But instead of an equal sign, they use a greater than, less than, or greater than or equal to, or a less than or equal to sign. So these are inequalities. This is what makes it an inequality. Okay? Now, when it comes to inequalities, it's literally the same thing as solving for x, but there's a certain type of rule that you need to know with certain types of questions. So I'm going to show you guys the difference. So let's say you had a question like this. 3x minus 1 is less than 8. Okay? And it basically says solve this inequality. So the question will say solve the inequality. So obviously we know it's an inequality because of the less than sign. So how are we going to solve it? We're going to treat this less than sign or greater than sign as an equal sign. So we're just going to treat it as is. So what I'm going to do first is I'm going to say 3x, and then I'm going to bring the 1 over to the other side. When the negative 1 comes to the other side, it becomes a positive 1. And then 3x less than 9. And then I'm going to divide both sides by 3. And what I'm left with is x is less than 3. So in this question, there's literally no difference between it being an equal sign and it being an inequality. There's no difference. So where does the difference actually come? That's what we're going to go through in this lesson. So let's say we had something like this. Let's say we had example 2, okay? Check this out. 35 minus 2x is greater than or equal to 20. So obviously we're going to solve for x. So we're going to say negative 2x greater than or equal to 20 minus 35, because I brought the 35 to the other side. Negative 2x greater than or equal to negative 15. Now look over here. Now we got to divide out this negative 2. Now this is where everything changes. And I'm going to make a note here. Whenever you divide, okay, so it's only when you do this, whenever you divide by a negative integer, the inequality flips. Okay, this is the key. This is the difference, okay? Because we divided by a negative integer, so you see how we divided both sides by negative 2? Due to that, the inequality is actually going to flip. So we're going to solve it as is. So negative 2x divided by negative 2, we're going to get x. But now the sign is actually going to flip this way. So notice how it was greater than or equal to, and now it's less than or equal to once we flip. That is the biggest difference. And then this would be your final answer. So with linear inequalities, this is the main rule that you need to keep an eye out for, okay? Whenever you divide by a negative integer, the inequality will flip. Okay, that's the key. That's pretty much the whole lesson, okay? So let's go into some other harder questions. What if we have a question that is a double inequality? Now, some of you guys may be like, what is this guy talking about? What is a double inequality? I'm going to show you, because you may get questions like this on a test, and it may be in like a thinking section or an application section. So let's say you had a question like this. 30 is equal to 3, 2x plus 4. I'm just doing an overkill question just to give you guys some perspective of how this stuff actually starts to manifest itself. So here you have a double inequality, right? Hence the word double, so we have two inequalities. So the way we're going to do this is first we're going to simplify the middle. So 30 is less than, we're going to expand this out. So we got 6x plus 12 minus 2x minus 2 less than 46. And then we're going to clean up the middle. So we got 6x minus 2x, which is 4x plus 10 less than or equal to 46. And this is how it looks cleaned up. But we can't just leave it like this. So now, remember, these questions, we're really solving the inequality. But when we're solving the inequality, what you're doing is you're solving the inequality for x, right? We're trying to solve for x. We're trying to isolate for x. So what we need to do is we need to isolate for x. So I want to get rid of this 10. But the question is, it's a double inequality. So what do? If I get rid of 10 from the middle, I actually have to subtract 10 on both sides. So if you look over here, this is going to be 30 minus 10. And this is going to be 46 minus 10. So notice how when I take the 10 out, I'm actually subtracting it from both sides. That's the only difference with double inequalities. You're subtracting from both sides instead of one side. With single inequalities, I just have to bring the 35 over to the other side. With double inequalities, I got to take that 10 and bring it over to both sides. So this ends up becoming 20 less than or equal to 4x less than or equal to 36. And then now, the same thing, I have to divide the 4, but I have to do it to both sides. So we'll get 5x and then 9. Okay? So hopefully this is making a little sense. Let's try another question. What if we have a fraction inequality? Okay? So let's try another type of question. You may get these fraction inequalities. So let's say I have x plus 4 over 2 is greater than or equal to x minus 2 over 4. Okay? If I have a fraction inequality, what I want to do is I want to get rid of this, right? So I'm going to take the 4, multiply it up, so I'll get 4x plus 4 over 2 greater than or equal to x minus 2. So all I did was I took this 4 and I multiplied it up here, right? Because it's being divided on the right side, when I bring it over to the other side, it's going to be multiplied. And then when I do that, I'm also going to, I can also do here, you know what might even be easier? I'll do it in one step for you guys. I'm basically taking the 2, I'm multiplying up here, and I'm taking the 4 and multiplying up here. This is called cross multiplication. So I'll have 4x plus 4 over 2 is x plus 4. So 4 times x plus 4 is greater than or equal to 2 times x minus 2. And then I'm going to expand it out. So 4x plus 16 is greater than or equal to 2x minus 4. And then we got to bring the like terms to each other. So I'm going to bring the 2x to that side. I'm going to bring the 16 to this side. So I'll end up with 4x minus 2x is greater than negative 4 minus 16. So we'll end up with 2x is less than or equal to negative 20. And then I'm going to divide by 2. So we'll get x is greater than or equal to negative 10. And this will be our answer for that. So with fractions questions, cross multiplication is a great strategy to have. Okay, let's go into a little bit of a harder one. I'm going to try something a little bit more tricky. Let's do this as the last example for this lesson. So what if I had something like this? X plus 6 is less than x plus 2, 5x plus 3. So in this question, I'm actually going to have to FOIL out the left side. So we'll get 5x squared. So remind you, we're FOILing. So we get 5x squared plus, 3x plus 10x plus 6. And then we're going to keep chopping it up. So we're going to have x plus 6 is less than 5x squared plus 13x plus 6. And then here's a little tricky because we only have this x squared term. So yeah, the x and the 13x we can simplify because they're like terms, and the 6's we can simplify. But what are we going to do with the 5x squared? So in this case, I'm going to bring both of these terms to the other side. And when I bring both of the terms to the other side, I'm just going to get 0. So we'll get 5x squared plus 12x, and then obviously the 6 and the 6 are going to cancel each other out. So when I bring the x over, it'll be 13x minus x, which is 12x. And then when I bring the 6 over, it's just going to be 6 minus 6, which is 0. So then I'm left with this. Now here, I can actually factor out an x from this side, and I'll get 5x plus 12. And this would be my answer for the inequality. So notice how this one, we had a quadratic. So that's what makes it a little bit different. So the main concept, guys, is you're pretty much performing the same orders of operations that you would perform if it was an equal sign. But the main difference is this. Whenever you divide by a negative integer, the inequality flips. So if you found this video helpful, guys, subscribe to the channel, drop a thumbs up if you found this helpful, share it with your friends in school, your classmates, and if you need tutoring, feel free to click the link in our description. Our tutors would love to reach out to you and help you out throughout this course. But without further ado, I'll see you guys in the next video.